Yes, no?
Okay, great. I'm sorry for the delay. Slightly, there were some slight technical issues. So I'm really excited that we can start now. A presentation about one of my favorite projects recently, and that's Eclipse GLSP, which is a new incubation project. GLSP is short for the Graphical Language Server Platform, and it allows you to build diagram editors in cloud-based modeling tools. So basically, this is in the context of creating your own cloud-based modeling tools, especially when you're thinking about graphical diagrams, which you can edit. One thing that is very important to us in many use cases is that we can enable those diagram editors, but still integrate those editors, which run obviously on the client, with the Eclipse modeling project, or the technologies of the Eclipse modeling project. And since the Eclipse modeling project provides so many functionality, this opens up, of course, a lot of features and opportunities. In order to allow us to use the Eclipse modeling technologies for building diagram editors that run in a browser in a cloud-based environment, we obviously need some sort of client-server architecture. So basically, this not only allows us to reuse those technologies that are Java-based that can then run on the server, but it also allows us, makes it much easier to migrate also existing diagram implementations into a browser-based or cloud-based modeling environment. The third reason why we really need a client-server architecture for our use cases is that very often we are dealing with the fact that one diagram is not one model. So very often we have multiple diagrams which each represent different parts of a larger model, and obviously we can't load the entire model into the browser so that the browser knows about everything. However, for a good editing experience in a diagram editor, you really need to have this whole model understanding in order to provide good usability. So for instance, when you change in this diagram editor, you change this node, which also shows up in the other diagram. You want to change it immediately also in the other diagram editor, so you need to have a whole model understanding. And this whole model understanding can be encapsulated on the server if we have a client-server architecture. And implementing such diagram editors more and more in the last years, we more and more realized that this is essentially the same problem that's also addressed in the language server protocol for textual languages like C or Java or domain-specific ones. So for instance, when you have in one text editor a Java class open and another one another Java class, which is the superclass of this class, and you change this one editor, obviously there might be errors due to in the other editor due to a change in a separate editor. So we also need to have like a whole program understanding, and this is more or less the same issue. So, and this basically leads me to the main objective of the Eclipse Graphical Language Server Platform, and that's basically applying the architectural pattern of the language server idea to graphical modeling. Basically, on the one, first of all, to enable the development of web-based diagram clients and editors, and also to decouple the client implementation, like the diagram rendering and the edit tools and so on, from the actual language knowledge and language implementation that specifies the editing rules and all these things. So this know-how should really be encapsulated on the server. That also then allows us in the next step to reuse existing frameworks and even existing diagram implementations without having to re-implement them from scratch. Also, it addresses the management of large models, as I showed in the previous slide, and it is a really nice separation of concerns. It allows for a really nice separation of concerns, since the front end can really be focused on the diagram rendering and on the user interaction, but doesn't need to understand the entire diagram. So how can you think of that in terms of separation of concerns? When you look at a typical diagram editor implementation, this basically encodes several functionalities, starting from the actual diagram rendering, so how does the shapes and the edges look like and which types of them are available and so on. Then you have usually editing tools that you can use to modify this diagram, obviously. While you're applying those editing tools, you would like to see some visual feedback. So for instance, if you start an editing tool that you actually are not allowed to execute in a particular context, you should get like a forbidden marker or something like that. Those visual feedbacks therefore need to sort of visualize the editing rules that the diagram actually provides or defines. Once you eventually can apply an editing tool, a certain command needs to be executed on the diagram, which then manipulates the diagram, usually in an edit transaction. And then, of course, after each change, you would like to run live validations to have error markers and stuff like that. And eventually, you also need like things like model management and to reload, to load, serialize, and so on models. So when we now think about this client-server architecture again, where would we then put the cut between server and client? In GLSP, we are thinking about, or we actually currently designed it in a way that we basically cut between editing rules and visual feedback. So basically everything, every functionality that strictly depends sort of on the rendering technology has to be sort of client specific, because it has to know how things are rendered and so on. And everything that is only diagram specific and encodes the editing rules, the diagram rules is encapsulated on the server. However, of course, things like editing tools and visual feedback is also something that needs to be aware of the diagram rules, right? So when you have, for instance, class diagrams or sequence diagrams, they define which elements you can actually create, and what you can create is encoded in the editing tools, right? So how can we then do the split between a client that doesn't need to know everything about the diagram language and a server that encapsulates all the knowledge? And we do that by introducing sort of a protocol that the server that enables the server to parameterize especially editing tools and visual feedback on the client, so that as much as possible the knowledge is encapsulated on the server. So that's the main idea. GLSP provides for fulfilling this separation of concerns three things. First of all, there is a Java-based server framework, which is more or less a standalone server that you can fire up, and then which then understands this Graphical Language Server Protocol, over which we can send things like the language configuration. That's basically this parameterization that I was talking before, as well as for the client to send commands to the server to execute certain operations. Finally, it also provides a web-based diagram, client framework, which mainly provides things like connecting to a graphical language server, which can be integrated in Theia or can be used standalone, and which provides all the UI for editing support and whenever you use, for instance, some edit tools to send the appropriate commands to the server. We reuse a lot of things from the Eclipse ecosystem. So for instance, for the server implementation, we reuse Eclipse LSP4j, which is a framework to implement basically JSON RPC-based servers. That is great. And especially we reuse a lot from Eclipse Sprotty, especially in the client implementation. In a way, we don't just reuse it. Sprotty, in fact, is the rendering component to actually draw the diagrams then in the browser. And also, luckily, Eclipse Sprotty provides already a client-server protocol that we can use for transferring model representations from the client from the server to the client. So when we look at the interaction between a client and a server, how does that work? This first step work with Sprotty. I won't go into too much detail about Sprotty because there will be a great talk tomorrow. So when a client when a user decides to open a diagram, we initiate this client, and the first thing that the client does, it starts and initialize the graphical language server with, for instance, the URI to be opened. Next, the server then, from whatever data source, might be an EMF model or something like that, it reads the model and translates this into a sort of a JSON-based graph representation, which is basically looking like that. So that's more or less defined, well-defined in Sprotty, but you can even extend that. It basically talks about edges and nodes and types of nodes and sort of things. And then based on this JSON-based representation, the Sprotty client translates this essentially in an SVG, which is then rendered. So we get basically a nice interactive SVG diagram from that representation. If you want to learn more about Sprotty and how you can create actually the rendering about also inside of GLSP, I strongly recommend tomorrow the talk Graphical Views for Web-Based Modeling Tools with Theia and Sprotty by Jan and Miro. Is tomorrow at 10:15. So it will be for sure very insightful to learn more about this project. It's really awesome. Right, so once we have sent the diagram, the initial diagram to the client, where comes the editing configuration and really the editing capabilities into play. So we have here a couple of initialization messages that so that the server can teach the client which things actually can be applied in a certain context. So for the most obvious thing, for instance, is we can request the available operations. So the server would then read its language configuration and use its language know-how to know which operations can actually be applied, sends these operations back to the client, and the client can then render, for instance, a diagram palette where you can then choose from to create elements. Once, for instance, the user then decides to use this palette to create an element, for instance, the client just sends, without really knowing a lot about what this actually means, sends a create node operation to the server, and the server can then manipulate actually the model and sends back an update of the model so that we can again render the update. And I will just show you that in live, how that works. So I have here in the back already running a GLSP server, and here on the client, that's a Theia-based client, we have here a workflow file which contains all the diagram information. So I will just open that up, and what we see here is that we already received the information about the diagram itself so that it could be rendered, and we also received all the information which things I can actually currently create. So for instance, I can create an automated task, a manual task, and so on, but the client actually doesn't know what's the difference. It just uses this type IDs basically to identify those two, and the server applies those changes. When we look back to the server log, we exactly see what has happened. So in the first step, we requested the model, then we requested they requested the operations. Once we decided to actually create the node, we sent this to the server updated the diagram and sent it back, and so forth. Here it's important to say that the server has full control over that, and just to show you that this is actually true, I'm now in the server configuration code. So here is the definition of which operations should be available in the palette, and for instance, I can now rename this automated task into automated task 1, and I specify now that instead of an automated task, I will create a decision node. So I'll break the configuration a little bit. I just save, go back to the client, I reload. So now we received a new configuration, automated task 1. And as soon as we apply this node, you see that already without just changing anything on the client, we reconfigured the language so that everything is, so that the automated task node is different. Right. So what actually happens when you then run such an operation? So send this, for instance, this create node operation. Here comes the server framework, helps you the server framework to create those sort of action handlers. So when the client sends such a message, create node with a client ID and a type, for instance, and potentially a location where you clicked, the server will read the JSON message, will fetch your client and model state, for instance. Then there is an action dispatcher which looks up in a registry which action handler should actually be invoked, and then the action handler eventually will be executed. Here, only the action handler is usually language specific, obviously, so all these gray things are typically generic. So to define your language, all you need to do is basically create this initial configuration of which operations are allowed, and then write according action handlers for them. So in this example, the action handler is super simple. We just create some sort of node return this node, and then it will be added in the diagram. Of course, these can be in different scenarios also more complex. So for instance, when you think about a diagram implementation where we separate a semantic model which contains the information about the model, and from a notation model which only contains the information about diagram positioning and so on, then this implementation would be a little bit more complex, but it would mainly look like typical EMF code where you can, for instance, use the EMF generated factory to create a model element for this according to the meta model for the semantic model, and the same for the graphical, and then you just return that, and it will work similarly. Of course, any model manipulation is done on the server. That also means other action handlers like undo, redo. So for instance, when I go back to the diagram and I execute some task and I hit Ctrl-Z, then it's gone again. Of course, this undo is also applied on the server because only the server knows about the state. Right, one thing that I would like to highlight is that we would like to minimize client-server interactions. So for instance, consider you are creating an edge from one node to the other. So that's a typical user interaction where, maybe I best show it. When I create, for instance, an edge from here to another node, then we want to avoid that there is a server round trip whenever I hover over an element to ask the server whether I'm actually allowed to create this node here or this edge here. And that's basically, we try to avoid that by introducing a concept called type hints. So we have type hints for edges and for nodes. And that basically works as before. We request the type hints, and type hints basically specify for a node whether, for instance, it's you're allowed to move it, whether you are allowed to delete it, to resize it, whether you are allowed to move it from one container into another, and so on. And for edges, for instance, it specifies which types you are allowed to connect. So those are, of course, the simplest implementations of those type hints, but they probably work for 80%. If you need more specific things, then you can, of course, customize that. Just to show you that very quickly in a demo, I will go back to the diagram configuration, scroll down a bit to the node hints as well as to the edge hints. So maybe I can show you here first. We are allowed to currently resize those these decision nodes, which is cool. But now let's say we want to forbid that. So we just go into the decision nodes here. We currently use the default, which is basically allow everything. So let's just refactor that and inline that. Okay. So now we directly create the simplest implementation of the node hint, but we set this last flag to false, which is basically the whether you are allowed to resize something, so the last parameter. So now resizable false. Now we have to go back and reload because the configuration is obtained on initialization. And now suddenly we are not allowed to resize those anymore, those elements. Going back and try the same for edges. Whoop, sorry. So currently, for instance, we are allowed, let's create a merge node, for instance. We are allowed to create weighted edges only from, which ones? From these decision nodes, but we are not allowed to create those from normal node tasks nodes. So when we go back to the server and look at how this is implemented, that's basically these 4 lines. So we create an edge hint for the type weighted edge, and we specify that valid source element type IDs are decision nodes, and target type IDs are manual nodes, automated tasks, blah, blah, blah. So let's just here add that we are also allowed to create them from manual tasks, for instance. Now we go back and reload. And hopefully, if everything worked, we can create them also now from the manual tasks. So you see that's basically the main idea behind that is to minimize server round trips during direct server interactions. Of course, the model, the server has the last responsibility when executing things. So also if the type hints are not sufficient, the server can always decide to just reject the operation and send back the old model. You can see that that we, for instance, we are allowed, according to the configuration, to resize those manual tasks. But essentially, when we trigger such an operation, the server simply rejects those, so they will just get the previous size again. Good. What else to say, for instance, about the client framework? So here we basically just use Sprotty for rendering diagrams. So that means that we get all the greatness and flexibility that Sprotty allows us to do to visualize those diagrams. What we then add on top of that is basically only the editing tools and how they can be configured based on the protocol that I've just shown, as well as, of course, the commands for then executing those operations. We also added a couple of editing tools and capabilities to GLSP for this client. A few of those have actually also, those that make sense, have actually also been directly implemented in Sprotty, so they are available for all Sprotty-based diagrams. Some of them, of course, only make sense when you are dealing with the GLSP server, so those are then in the GLSP client. So let's look at what we can do here. So one thing, for instance, is that we can directly edit labels here, and maybe, for instance, rename that into test, QQQ. That's a typical editing tool, as well as we integrated things like a command palette, where you can then, for instance, create a decision node at a certain position and stuff like that, so to have really a nice editing experience. Good. Right. So with that base, so that's basically the main functionality of GLSP. With that, we started to investigate different directions to learn more about the flexibility and its potentials of this sort of idea. So what we did was, for instance, what I've showed you now was really the simplest way of applying GLSP, right? So we have a GLSP server that directly loads a graph model, so there is no transformation involved. What we did next, actually, is that we, instead of have this really simple implementation, hook it up to, for instance, a model server that actually reads a real EMF model, translates this into a diagram, and sends it back. Of course, that means that all action handlers now don't have to only modify the diagram, but actually the underlying EMF model, and then we go this loop again and generate the diagram. This essentially allows us also to hook up other servers that are working on the same model. And I can simply show that. So we basically use the same, exactly the same diagram client, but I will just go to the server again. I will kill it for now, this simple implementation of the server, and we'll start one that is actually based on EMF, where we actually modify a real EMF model. So now I go back to the client, just close that, we don't want to save. Now I reload, and what I can now actually open is here a separate, different file. So essentially it's exactly the same client, but to a different server implementation. And with that other server implementation, we can basically modify real EMF models. So when I just open this file here, which is a typical XMI EMF model, just make it larger a little bit, I create a new automated task, and I save, and you see it actually created a real automated task in the actual underlying model. So you can go arbitrarily complex what you actually do on the server. That's the main idea behind this demo. Finally, we can even go further and not only integrate existing modeling languages that we use and modify on the server, but we can actually directly hook it up to existing diagram editor implementations. So in this example, what we did basically is we took a tool that's called Papyrus UML Lite. That's a full-fledged UML editor, basically, that is customized for a specific use case. And we added a runtime API on top of it that we then hooked up with the GLSP server. So basically, it just translates it into the protocol. And with that, we actually were able to directly attach a GLSP client here, running on the right, to a running instance of this UML Lite rich client on the left side. And as you can see, we can then basically get exactly the same diagram, we can apply the same changes, and they will be updated live without doing anything more than just forwarding all the implementations of the language server protocol to the actual diagram implementation in the editor. So this really opens up great flexibility and especially great reuse to not have to implement everything from scratch, but you can very easily make available existing diagram implementations in a web-based client. Of course, it also works in the other way around. Let's just wait until this video is finished because it's so nice. Now it's done. Right, something similar has been presented this morning by Rainer, where they showed that they have an existing function block diagram implementation that has also been hooked up with GLSP, and with that we could also see that with GLSP we can reuse quite a lot of existing diagram implementation code, but still be able to make this diagram implementation available in cloud-based modeling tools, which is actually really great. Okay, unfortunately you missed the talk because it was this morning, or if you were there then it's good, but you make sure you can catch it on YouTube later. Right, and last but not least, I would like to hand over to Martin to present yet another use case.
So another really cool and interesting thing we did was that we wanted to reuse the GLSP server for the workflow model example and just create a completely different client. And in this case, we created a GLSP client for an augmented reality device, namely the Magic Leap 1. So what we did is we wrote an application for the Magic Leap 1, which communicates with the GLSP server and then takes the JSON-based format we get from the server and translates it into something that device can actually render. So what we end up with is a diagram basically you can place anywhere in the room, and I will show you a video of that in a second. As I mentioned, just a video, so if you're interested in actually seeing the device, there's a talk tomorrow by Jonas, Property Editors in Space, so you can also catch that talk live. I would really recommend that if you're interested to see that. And without further ado, let's see if the video starts. So you kind of put the device on your head. There are a couple of applications already installed on the device, but you select our application. You can see that the room is kind of scanned, and you place it, and you have again a model similar to the ones that Philip has shown. Basically, what we can reuse here is the device already has a library for different UI elements like buttons, lines, and so on. Yeah, and that was really fun to do. It also opens up a lot of interesting ideas about user experience, so you kind of can walk around the diagram and have interesting interactions. But yeah, so that is what we did for that, and all without modifying the GLSP server. Back to Philip.
Thank you, Martin. Right, that brings us to the end of this talk, so just a few conclusions. I think what's really, especially this last example showed is that this strict separation of concerns actually opens up a lot of opportunities in terms of flexibility. We've seen in the previous example that we can just replace the client and leave the server as it is and just implement it based on different clients. Of course, the augmented reality is a very fancy way of doing that, but you can also think of a rich client implementation and a web-based client implementation. We've also seen that we can exchange the server while keeping the client exactly the same, so that we can have EMF-based or any other based servers. So that's pretty cool. Another conclusion that I would really like to highlight is, as you have seen, we use Sprotty as a rendering and client-side diagram framework, and I can really recommend this project. It allows for developing really nice and beautiful diagrams, and it provides great flexibility without a too steep learning curve. Last but not least, we have used it now in a couple of projects, GLSP, and our experience so far is that it really allows for very high reuse when you are migrating existing diagram implementations into a web-based or cloud-based IDE. And in my opinion, it's still a very young technology, of course, but depending on your use case, you can already apply it for quite a large number of different diagram types. I think. Please feel free to just go ahead and try it or give it check it out. And if you have any questions, of course, always feel free to contact any of us. Just a few words about the outlook, what we are planning in the future. So just to maybe to give you an update on the state, so it's currently is an Eclipse incubation project. We already did the initial contribution, which is currently under IP review, so we expect the code to be in the Eclipse repository in the next couple of 1 or 2 weeks maybe. But if you want to check it out already now, you can also use our currently existing GitHub repository. What we plan to then add after this is done, we plan to add property view support based on JSON forms, for instance, so that you have really the typical diagram editing capabilities. And also then, of course, we want to further enhance the editing capabilities in the client in general, so that you have really a full-fledged diagram editor. Also, what's currently, we are trying different ways of achieving that. So I've presented the edit hints before, like specifying what you're allowed to do with a type node, with a node or an edge type. So currently we only do it based on use case by use case to see what we need to really support there. And we are trying to find the best balance between powerfulness and simplicity here. But so far, we cover, I would say, 80% of the use cases, but you might have very specific ones where we then need to customize. So I hope you enjoyed this talk. I would be really looking forward to getting your feedback. As I mentioned before, it's a young project, and we would be very thrilled to get your feedback and use cases to learn what we need to add to this generic framework. Thank you very much. Are there any questions already now? If there are no questions right now, then of course feel free to find us at our booth, and here are also our email addresses. We are looking forward to answering any questions that you might have. Thanks, and enjoy the rest of the day.